Welcome to our lesson on turning points of polynomial functions. This is an essential topic for Class 11 and JEE students, where we'll explore maxima and minima in detail. So, what exactly is a turning point? A turning point of a function f, x, is a point where the graph changes direction. There are two main types: a local maximum, where the function goes from increasing to decreasing, and a local minimum, where the function goes from decreasing to increasing. Now, let's look at the procedure for finding turning points. There are three main steps. First, compute the first derivative of your function. Second, find the critical points by solving the equation f prime of x equals 0. Third, use the second derivative test at each critical point to determine whether it's a maximum or minimum. Let's break down the second derivative test in more detail. If the second derivative at point is less than 0, we have a local maximum. If it's greater than 0, we have a local minimum. If it equals 0, the test is inconclusive, and we need to use the first derivative sign chart instead. Now, let's work through a complete example. Consider the polynomial function f of x equals x cubed minus 6x squared plus 9x plus 1. First, we find the derivative. F prime of x equals 3x squared minus 12x plus 9. We can factor this as 3 times the quantity x squared minus 4x plus 3, which further simplifies to 3 times the quantity x minus 1 times x minus 3. Now, let's find our critical points by setting the first derivative equal to 0. 3 times the quantity x minus 1 times x minus 3 equals 0. Since the product is 0, either x minus 1 equals 0, so x equals 1, or x minus 3 equals 0, so x equals 3. So our critical points are at x equals 1 and x equals 3. Next, we need to find the second derivative to determine whether each critical point is a maximum or minimum. The second derivative is 6x minus 12. At x equals 1, we get f double prime of 1 equals 6 times 1 minus 12, which equals negative 6. Since this is less than 0, we have a local maximum at x equals 1. At x equals 3, we get f double prime of 3 equals 6 times 3 minus 12, which equals 18 minus 12, which equals 6. Since this is greater than 0, we have a local minimum at x equals 3. Finally, let's calculate the y-coordinates of these turning points. For x equals 1, we have f of 1 equals 1 cubed minus 6 times 1 squared plus 9 times 1 plus 1, which equals 1 minus 6 plus 9 plus 1, which is 5. So the local maximum is at point 1, 5. For x equals 3, we have f of 3 equals 3 cubed minus 6 times 3 squared plus 9 times 3 plus 1, which equals 27 minus 54 plus 27 plus 1, which is 1. So the local minimum is at point 3, 1. Let's visualize our function and its turning points on a graph. The blue curve represents our polynomial function, f of x equals x cubed minus 6x squared plus 9x plus 1. Notice the local maximum at the point 1, 5, shown in red, and the local minimum at the point 3, 1, shown in green. At these turning points, the tangent lines are horizontal, indicating that the first derivative equals 0. Let's summarize what we've learned about finding turning points. First, turning points occur where the first derivative equals 0. Second, use the second derivative to classify whether it's a maximum or minimum. If the second derivative is negative, it's a local maximum. If the second derivative is positive, it's a local minimum. Third, if the second derivative equals 0, the test is inconclusive, and you need to examine the sign of the first derivative around that point. Finding turning points is essential for understanding the behavior of polynomial functions and has important applications in optimization problems. Practice this method with different polynomial functions to strengthen your understanding and prepare for your exams.